Hello, we will be presenting our PIA project for the subject of study of change, and these are our team members. Part 1, Introduction to the problem. Here we will solve a problem that could happen in everyday life by using calculus. And in this situation, we have that the mayor of Monterrey placed an order to manufacture water storage tanks with a capacity of 0.1 meters cubic for each citizen per day. However, he is missing the dimensions. Which dimensions should the tanks have to ensure that each one uses the minimum amount of material to make?
First, we need to identify our variables. The dependent variable we want to minimize is the amount of the material, and our independent variables are the radius and the height of the cylinder. We know the volume of the drum must be 100 liters or zero point 0.1 cubic meters. Part 3, formulation of the optimization variables. To find the surface area of the drum, we use the formula volume is equal to P times radius to the square times height, and substitute it into the surface area formula, that is 2p times radius times height plus 2p times radius to the square. This gives us height equal to zero point 0.1 over p times radius to the square.
To start this problem, first we need to calculate the total external area that is expressed like this. The first part of the function aims to calculate the area of the two faces, the bottom and the top. And the second part of this equation aims to calculate the extended face of the cylinder respect to the volume that it is expected to contain. In this case is 0.1 meters square because we need to contain 100 liters. Then when we got this, we need to simplify the second part. We got this, that is 2p times 0.1 over p and radius square. We can cancel the p and the 1 radius over there to get 2p radius plus 0.2 over radius.
So after doing the analysis of using the volume formula in the surface area formula and getting the derivative, we can now get the value of x that minimize the dependent variable, which is the radius equals to the cubic root of 0.2 for p. We get a value of this and we get the radius is equal to 0.251539. After this, we can now use it in the volume formula in order to get the height of our cylinder, which will be 0.2 equals p times radius square h. We pass these ones dividing to the other side, and it will give you that the height is 0.5382 meters. So with this, we can conclude that, well, we can get a minimum local minimum, which will be our radius that we get, which is our x will be minimize that dependent variable, which is 0.25. As you can see, in the first interval we got that it is decreasing, and in the second interval we got that it is increasing. So in order for our drums have the minimum material but maximize the efficiency, it has to have a 0.25 radius.
After you have this simplified version of the equation, you have to find the derivative of the equation. After you follow all the rules to find the derivative, you'll get 4p times the radius to the cube minus 0.2 meters cubed. Then you have to make the derivative equal 0. Make the equation equal 0. So it's 4p to the radius to the cube minus 0.2 equals 0. You then want to solve for r, or radius. So you do 4p radius cubed equals 0.2. Then it's equals 0.2 over 4p, which then gives you radius equals to root square, cubic square of 0.2 over 4p.
Okay, so after watching the calculations, we can state some things about the problem. At first, we can say that our cylinder uses less material than the first cylinder that we had. With this, we can confirm that our dimensions minimizes the material cost. These exercises help us to show how calculus can help us on some problems that we could have on a future time, such as reducing cost or maximizing cost. So that would be it for the video. Thank you so much for watching, and we hope you learned something today. Bye bye.